In this video, we will continue taking a look at the files. So here, we'll open the bundle config.json, and this file is responsible for bundling and minification. These are two distinct performance optimization you can apply in a web page. Used together, bundling and minification improve performance by reducing the number of server requests and reducing the size of requested static assets. Now if you take a look at the first file here, we see output file name, and it is a minified file name here, but the input, if you see, it's not a minified CSS file. Also, we have the same for JavaScript down here. So here the input file is site.js and the output file name is the minified file name. And another option here is the minify option, which has been enabled to true. So you can set all of these options of bundling multiple CSS files here so that you can save the efficiency by reducing the size of static request. Now in classic ASP.NET, which uses system.webassembly, which took care of starting the application, and then there was global.asax file where you could provide custom logic. But this file no longer exists in the ASP.NET Core 2.0. But now the steps needed to start an application would be determined by you. We have a program class in our solution which contains main method. So let's open that up. And here we see a main method. So when the runtime executes the application, it looks for this method and calls it. The application starts initially as a command line application. The main method configures ASP.NET Core and starts it. The configuration is done by calling the build web host, which is a method in the program class itself, and it returns a iWebHost object. On that object, run is called, and from that point onward, the application transitions to an ASP.NET Core application. The web host builder is also configured to use a startup class called Startup.cs here. So if we go back, we see we have a startup here. So if we go back to the class of startup, you see this class is not deriving from any other class. In startup class, the runtime will call two methods called configure services and configure. So first it would call the configure services and then it will call the configure method. The role of configure services method is to configure the dependency injection. In ASP.NET Core, dependency injection is an integral part of the application. Here, we would be registering services we want, like if we are using ASP.NET Core identity, or if we are using DB context to connect to database using entity framework, we would have to define them in the configure services. Since we created the project as an MVC project, ASP.NET Core has already added services.addMVC to add MVC to our services. The other method is configure. This method configures the HTTP request pipeline of ASP.NET. The pipeline specifies how application should respond to HTTP request. When your application receives a request through the browser, it goes through the pipeline and comes back. You will have to plug in stuff you need in the pipeline. In the classic ASP.NET, this pipeline was pre-filled with all the stuff, which will include the stuff that you would never use, which decreases the efficiency. Let me switch to presentation here. So here we have a browser, and then we have a pipeline, and then there will be a request and a response back. The individual parts which make up pipeline are called middleware. In our case, we have MVC, and then in the later videos, we would also add authentication to our project. So that would add another middleware. But you should notice here that authentication should be placed before MVC so that when a request comes in, it is first authenticated and then MVC will come in the picture. We also have to configure middleware for the static files which we have, like JavaScript and CSS. Now when data travels through the pipeline, it gets manipulated by individual middlewares, and so does the response or the result. Now let's take a look at a 10,000 foot image of what happens when a request is made. So the request is made from a browser, and first it arrives at a web server like IIS. IIS would then invoke the .NET at runtime, which would load the CLR and then look for an entry point in your application. It would find that in the main method of the program class and execute it, which starts an internal web server in your application. We will have Kestrel in our application. The main method and the startup class would configure the app, and request would be routed from IIS to Kestrel, and then it would be pushed to application and then processed by all the middlewares and generate the response and route it back to Kestrel, and then it will route it back to the IIS, which will produce the response on the browser. This is much more efficient than the old system.web approach. Classic version relied heavily on system.web, which was tied to IIS. But using pipeline approach, you only plug in what you need, and everything you plug in is a separate assembly exposed in NuGet. Now, since system.web was tied to IIS and IIS is tied to Windows, that is the reason you cannot run classic ASP.NET applications on other web servers than IIS and Windows. Now, since that is no more the case, ASP.NET Core applications can be run on other app servers and operating systems. Now keep in mind there are two web servers. One is the external like IIS, Apache or Linux. There is also an internal web server hosted by your app. Requests from external web server are passed to the internal web server and other way around. You can also choose different internal web server, but the most common is Kestrel since it has a first-class support in ASP.NET Core. Kestrel is a lightweight web server which can only execute a request, because of which you need external web server to configure other options like security, caching, etc. Now let's switch back to the application. So that was just an overview of how middleware comes into picture and how pipeline comes into the complete flow of a request. So I'll see you guys in the next video.